Hi, I'm Alikhan Zhumabayev, and this is my project. It's the skin disease classification model, and it's a ResNet 18 model that was created on the Jetson Nano. In order to use the model, you need to download Python 3 and the Jetson Inference library on the Nano before you do anything. After that, you need to download the ResNet 18 Onyx and the model best PTH tar. That's the pre-trained model that I created with a skin data set of multiple different skin conditions. I aim to diagnose whatever skin condition that anyone may have so that once they have more knowledge of what the skin condition is, they can better treat it. I use the NVIDIA Jetson Nano Developer Kit, and I use my computer, which is a MacBook Air M1 chip. You need to follow these instructions. It's in the README, and here's the collection of images in a Google Drive folder. Anyone can use the link, so just make sure you're signed into Google and have a Google account before you open the link. This is a lot of images. I tried to use as many images as I could find. I found a data set of images on Kaggle, and I switched the images. I found the images on Kaggle, which is a dataset website, and then I filtered the images so that the majority of them would go into a train folder, and then the rest would be filtered into a test folder and a validation folder. In order to run the model, follow the directions in the README. First, cd to the classification directory, which is in training, which is in Python. Then you need to set the network model as the disease model and the data set as skin disease. This is the skin disease data set I was mentioning earlier. Then you use this command to process an image. There are different spots here, as in put tester trainer val here, type and picture you want to check and what you want it to be named, .jpeg here. Those blank spots you need to fill in with the name and folder and directory of your image. For example, 0/0 on who 0216.jpg is inside the test folder in unknown or normal right here. Then normal.jpg is the name that it's going to show up as. This is going to help you identify which image is your result because there's a lot of files in here, so it's easy to get confused. If you want to add your own image, add it to a directory under the test directory, which is right in here, and use the command above, replacing the names with the directories and names of your image. That's what I was talking about earlier, when you got to make sure that it's going to the right image and not any of these. This is part of the unknown normal one, so it can help detect whether the skin condition is actually there or if there's nothing showing up on the screen. Like if I was going to check right here, hopefully my model would classify this as unknown or normal because there's no skin there. I added a TV and many other things in the unknown normal section. There are many animals and trees here, many random stock images to try to give the unknown normal class a sense of randomness. This may have impacted the model's ability to train itself. Unknown normal class could have skewed the data. Let's try some of the images. So you have to CD into, CD means move directories to. You have to CD into Jetson Inference, then Python, then training, then classification. Then you run this command. This is the skin disease model. This is where you put test or trainer val. I put test because it's inside of the test folder. And then acne, and then acne pustular 22.jpg. That's the name of the actual image I want to test. I want it to be renamed acne.jpg when I run it so that I figure out what it is. It might take a while, which is why I have the NVIDIA Nano. It has a lot of processing power, which helps. I would like to use more processing power so I could train the model better the next time that I do this. Here you have to refresh the Explorer because sometimes the image does not show up on the first try. Once I refresh, it's here, acne. It recognizes it as acne and it gives the percentage of confidence that it has. Here it's 21% confident that this is an acne image. I wish that this could be a higher percentage. So if I were to do this again, I would make sure to train the model with more images and so that it's more thorough in how it does the work. Let's try another image. There are many different skin conditions in here that I could have included into the classes because not all skin conditions fall under these categories of normal, moles, eczema, infestations, sunlight damage, skin cancer, acne, warts, and benign tumors. But if there are going to be too many classes with the amount of computing power that I have, I don't think it would be feasible because it would have too many different classes to differentiate. And I don't think the model would work as well. Here's mole.jpg. It figures out it's a mole. That's great. If someone was going to put a picture of a mole just like that onto the screen, hopefully the model would identify it as what it is, as a mole. This is the last image. Third tries the charm. There's a lot of work going on in the terminal. So if you have a computer with less processing power, you should make sure it's connected to power so that it doesn't drain the battery too much. I need to connect my computer to power. It's a pretty bad habit I have. Now, let's check tumor.jpg. Perfect, benign tumor. That's exactly what we're looking for. I'm really glad that my model's worked out the way it has. I trained this model with about a week's worth of training because I used originally 34 epochs, but 34 epochs did not give enough accuracy. 34 epochs only gave about 30% accuracy. Once I moved up to 45 epochs, it went to about 40% accuracy. I thought that this would mean that the more epochs I did, the more accurate it would become, but that was actually not the case. When I moved to 60 epochs, it went down to 37% accuracy. This might be because of the data. When I went to 120 epochs, the accuracy went up to 49% accuracy. But then I realized the more that we run it through with these epochs, one epoch is going through all the images once. So if we run it through 120 times, I thought this just might be the nano memorizing each image and learning what it is. So I did not want that to happen because that means if someone was going to bring a new image into the model, which is the reason the model has been trained for other people to use it, then it would have difficulty distinguishing what the new photo was because it did not memorize it earlier. I then used 34 epochs again. I reset the model and I used 34 epochs and it came out with 35% accuracy. If I was going to run this project again, I would use more epochs, more images, but I would have less classes here. I would definitely remove the unknown normal class because it may have skewed the data. If we look inside here, there are many different images that have no relation at all. They're meant to be unknown, as in the model would know when there's no data in front of it, when there's no skin in front of it. But I don't think that helps with the amount of epochs that I ran. I did not run that many epochs, only 34 epochs, and I did not have enough computing power and I did not have enough images for this unknown normal class to be necessary. If I were going to have more images and more computing power so I could have ran more epochs, then I definitely would have included unknown normal. But I think that unknown normal could have just confused the model with the small amount of epochs that I was running. I don't want the model to have to figure out what this is. I want it just to figure out the difference between like very similar things, sunlight damage acne. This is pretty rudimentary of a model because I did not train it as long as I wished I could have. I had about 18,000 images originally in other classes, but I removed those classes because I thought it would confuse the model too much. Then I filtered some images into a test folder and a validation folder from the original training folder. I kept a lot more images in the training folder than I did in the validation and test folder. Here, after you do your pictures and then you figure out what they are, you can delete the images that you tested from the code because it's really unnecessary once you figure out what it is. You can run it again as many times as you want, and it should hopefully give the same data. Thank you very much for listening. This is my skin disease classification model. Just before I finish, I'm going to show you all my files. This is my Google Drive with all of the work in it. Well, all of the images. Here you go. There is a lot, and it's kind of gross to look at, but it's necessary if you want to use this. Take care.